Good evening students and welcome back to the session. So today I am here with you people and we will be discussing like 10 very important questions from JEE Advanced Pattern paper. So without wasting even a single minute, I would like to start with the question answers, that too very quickly. So let's see what is the first question that we have. Okay, so the question number 1 that we have is, assuming each salt to be 90% dissociated. So these are a few salts which are given to us and we are assuming that 90% of them will undergo dissociation. Which of the following will have the highest boiling point? Okay. Now see, you know, right, delta TB is equal to I into Kb into molality. We should not be talking about molality because see, everywhere we are given the same. So decimolar, decimolar, decimolar. So same concentrations are given. So let's not talk about molarity or molality. Since all of them are aqueous solutions, so let us not be talking about Kb, but you can see, right, that delta Tb is directly proportional to I. So more will be the value of I, more will be the elevation in boiling point, and now we know delta Tb is equal to Tb minus Tb naught. Since Tb naught is same, so we can say more will be the value of I, more will be the value of Tb. Okay. So I basically is the total number of particles that you will be getting. So see, Al2SO4 thrice will be giving us 2Al3 positive plus 3SO4 2 minus. So I is having a value of 5 by 1, which is 5. BaCl2 will give us Ba2 positive and 2Cl minus. So making us give the I value 3. And here in Na2SO4 will again have 2Na plus and SO4 2 minus. So once again the value of I is 3. So we can simply say that wherever the value of I will be maximum, in that particular case the boiling point will be maximum. The fourth is, so for sure not this, not this. A solution obtained by mixing equal volumes of B and C. So when you mix equal volumes of B and C, then also see like half volume. So half of it you will be mixing. So overall will come 1.5, overall will come 1.5. So 1.5 plus 1.5 will give you 3. So again not this. So option number A, where the value of I is 5 with a maximum value, will be having the highest value of boiling point. So option number A should be the correct option for this particular question. Okay, this was a really easy but an interesting question. So now since we are done with this particular question, let us now move on to another question, our question number 2. But just give me a minute. Let me clean the board. Okay. So now when I am asking you to move on to question number 2, it says that when 20 grams of naphthoic acid, so the naphthoic acid is C11H8O2. So you have taken 20 grams of naphthoic acid is dissolved in 50 grams of benzene. The Kf is given to me. Now see, the Kf is given to us of benzene because benzene is taken as a solvent here and this is 1.72 Kelvin kg per mole. A freezing point depression of, that means delta Tf, will be 2 Kelvin will be obtained. So you need to tell me what should be the Vance-Hoff factor I. Okay. So once again a very simple and a direct question. We know delta Tf is equal to I into Kf into molality. Delta Tf is 2 Kelvin. I we need to calculate, multiplied by Kf is 1.72 Kelvin kg mole inverse multiplied by molality. So molality is given mass by molar mass. So we can easily do the calculation of molar mass divided by mass of solvent in kg. So 50 to be divided by 1000 kg. Okay. So if I am asking you to substitute the molar mass, so molar mass you can see C11H8O2. So molar mass will be 12 times 11 plus 8 times 1 plus 2 times 16 grams per mole. Right? So let me just write molar mass into grams. Mole will go in the numerator. Right? Now see, if we can cancel out something, Kelvin will get cancelled, kg will get cancelled, mole will get cancelled, gram will get cancelled. You know everything. You can just figure out the value of I, which will come out to be 1 by 2. So I have done the calculation earlier. So the value of I that I got is 0.5. So marking option number A as the correct option for this particular question as well. Okay, again like a very good and interesting question. So since now question number 2 is also okay, let us move on to question number 3. But again, before that, just give me a second. Now if I ask you to go for question number 3, let's see what is question number 3. Question number 3 says that it's a kind of theoretical question, no such calculations are there. A cylinder which is fitted with a movable piston contains liquid water in equilibrium with water vapor. So a cylinder is there and the cylinder is connected to a movable piston. Okay, it contains liquid water which is in equilibrium with water vapor. So certain liquid water is there and water vapor are there. They are in equilibrium with each other and the temperature is 25 degrees C. Okay, now he is saying which of the following operation will not result in a decrease in equilibrium vapor pressure at 25 degrees C. So I basically want, so see, listen to the question. I am saying that what should I be doing so that there should be a decrease in vapor pressure. So we want a decrease in vapor pressure. But the question is little different. The question says that which of the following will not bring about a decrease in vapor pressure. Okay, so let's do both the way around and let's find out the answer. So first he is saying moving the piston downward a short distance. When you press the piston in the little downward direction by a very small distance. So see, don't you think we will apply the Le-Chatelier's principle here? I am saying that the liquid and vapor are already in equilibrium with each other. So when you push the piston in the little downward direction, then what will happen? You are increasing the vapors, right? You are asking them to undergo condensation. But according to Le-Chatelier's principle, the piston would like to come up and thus evaporation will be there. So there won't be as such a decrease in vapor pressure. So I mean this will be the correct option because we have to say will not result in the decrease in vapor pressure. So A will not result a decrease in the vapor pressure. Option number B says removing a small amount of vapors. So again you have to apply the Le-Chatelier's principle. If you remove a small amount of vapors, then I agree that the vapor pressure should decrease. But at the same time equilibrium would want to re-establish itself. So more of vapors will be created and vapor pressure will increase. Therefore removing a small amount of vapor will again not be resulting in a decrease in the equilibrium vapor pressure. Third is removing a small amount of liquid water. If you remove a small amount of liquid water, then once again you would have thought that if liquid water is getting removed but in a smaller amount, the equilibrium will re-establish itself. So more condensation will take place and hence again the equilibrium will be established. So even this is not going to result in the decrease in the equilibrium vapor pressure. However, he is saying dissolving some salt in water. When you will dissolve some salt in water, then I am very much sure. So he is saying that you have to dissolve some salt. So see, You know, right, colligative properties are effective even if you add a very small amount of solute. So when some salt, some non-volatile solute will be added, it will be covering the surface also. So it will lead to the depression, it will lead to a decrease in the vapor pressure. So only this will lead to a decrease in the vapor pressure. So the correct answer according to this particular question will be A, B, C. Easy one, right? Not a tough thing. But the question was really interesting. The question was really messy, because if you would have misread the question, then you would have written answer number D as the correct. But the question was asked in an opposite fashion. Good catch. Okay, so moving on to question number 4. Question number 4 says that, it's a statement type question. So there were 4 options which I didn't mention because they are well known to everyone. Option number A, statement 1 is correct, 2 is correct, and 2 is the correct explanation of first. B part was 1 is correct, 2 is correct, whereas 2 is not the correct explanation of 1. Third part is 1 is correct, 2 is false, and D is 1 is false, 2 is correct. Okay. So first statement says that addition of ethylene glycol. Leave ethylene glycol. By the way, the formula of ethylene glycol is CH2H, CH2H. Addition of ethylene glycol, which is a non-volatile substance, to water will lower the freezing point of water, hence it is used as an antifreeze. That is correct. Like whenever you want to reduce the freezing point of water, whenever you want that water should not be freezing at 0 degrees C, rather it should be freezing at minus 0.6 degrees C. Okay. So you add ethylene glycol because yes, it will lower the freezing point of water. Okay. So the statement 1 is correct. So the option could be A, B, C. D cannot be the answer. Now another statement, if I read, statement number 2 says that, so this is wrong. Statement number 2 says that addition of any substance to water lowers its freezing point. It is a wrong statement. So in first go, this might appear to be the correct statement, that whenever you are adding anything to water, it will bring about a depression in freezing point. But knock, knock, knock. Think carefully. We have already done that whenever you want to go for a depression in freezing point, you need to add any non-volatile substance. Until and unless you mention this word, a non-volatile substance added to water lowers its freezing point, the statement won't be correct. So I will say statement 1 is okay, but statement 2 is not the correct option for this particular question. So if you want to make sure that there has to be a depression in freezing point when something is added to water, then that something has to be a non-volatile substance. Okay. So thus if options would have been given, then option C would have been the correct answer for this particular question. So this was the statement type question that I wanted to discuss with you, and I hope I have made the question clear. Now if I ask you to move on to another question. So question is, what will be the molecular weight of calcium chloride determined in its aqueous solution experimentally from the depression of freezing point? That's really a good question. So see, when you are taking aqueous calcium chloride, this is going to give you Ca2 plus aqueous plus 2 times Cl minus aqueous. Okay, and you know that I is observed colligative property divided by actual colligative property, right? Whereas it is having an inverse relation with the molar mass. Fine. So I say that if the value of I in this particular case is 3, that means it is greater than 1. Then I will say the molar mass that you will be getting, so the experimental or the actual molar mass will be lesser than the theoretical molar mass. So theoretical molar mass is 111 grams per mole. So the actual molar mass that you will be getting will be lesser than 111. Okay. So this we have already done, that molar mass and I have an inverse relation. So if I is equal to 1, then the molar mass will be actual as well as it will be experimental, same thing. But if the value of I is greater than 1, then the value of molar mass will be lesser than the calculated molar mass. Fine? So the answer for this question is answer number B. Clear? So this was again a direct question, but this was direct only for those students who actually remember that the molar mass is having an inverse relation with the I value. So if I becomes greater than 1, then the molar mass will be found to be lesser than the theoretical value. So this is how we have done our question number 5. So now let us do one thing. Let us now move on to our another question, which is question number 6. But before that, I would like to clean the board once again since it's too messy. So half of the paper has been done and we are left with another half. Let's try to wind up that also. Okay. Moving on to question number 6. So when I have to move on to question number 6, I'll say the vapor pressure of a solvent decreases by 10 mm of Hg. So that means delta P, okay, which is what? The lowering of vapor pressure is 10 mm of Hg when a non-volatile solute was added to the solvent. Okay. The mole fraction of solute in the solution is, the mole fraction of solute in the solution is 0.2. Okay. So what can we conclude from here? So see, we know, right, the relative lowering of vapor pressure is equal to the mole fraction of solute. So I am not assuming any association or dissociation since nothing is referred. So we have 10 divided by P naught is equal to 0.2, right. So this could be written as 2 by 10. So we have 10 by P naught is 2 by 10. So we will have P naught is equal to 50 mm of Hg. So now we got the vapor pressure of pure solvent. Clear? Now the second thing he says is, what would be the mole fraction of solvent? This time I want you to calculate the mole fraction of solvent if the decrease in vapor pressure is double. That means if delta P is 20 mm of Hg. So now let us do the calculation once again. So now I'll say delta P by P naught is mole fraction of solute. Once again the same formula. This time delta P is 20. Whereas P naught value is what? P naught value is given to me as, so we figured it out, right, 50 mm. So this will come out to be the mole fraction of solute. So which is 2 by 5. Okay, so I can simply say the mole fraction of solvent will be 1 minus 2 by 5. So which will be 5 minus 2 by 5, which is 3 by 5, 0.6. Not a tough question, but yes, a good question. I mean, if you people are good, then you would have done the question even more quickly compared to me because I have solved everything completely. So for you, this question should have been, so such kind of questions are also asked in JEE, not because they are very simple, but because they want to check, they want to test how fast you can do a simple calculation and can get a quick +4, okay? Okay, so this was our question number 6. Having done with question number 6, now we need to move on to Another question, which is our question number 7. So let's see, question number 7 says what? Question number 7 is, which of the following solutions are isotonic with respect to 0.5 molar NaCl? We know NaCl undergoes dissociation as Na plus and Cl minus. Okay. Having the degree of dissociation as 0.8. So it is not 100% dissociating. This is dissociating to an extent of 0.8 or 80% dissociation is there. So see, how will I do? This is 0.5. So see, my main aim is to calculate. We know, right, that pi is equal to I into C into R into T. So since I am talking about isotonic, so I need to make sure that pi 1 should be equal to pi 2. So I need to make sure I1 C1 R T1 is equal to I2 C2 R T2. But R are constant, temperature is also constant. So I just need to make sure that I1 C1 should be equal to I2 C2. Okay. So let us first calculate the value of I for NaCl. So NaCl is 0.5. This is nothing, this is nothing. So now if this gets dissociated to 100%, so this will be 0, this will be 0.5 and this will be 0.5. Okay. So let's try to do the calculation by taking into consideration alpha. So this is 0.5 minus 0.5. So see, let alpha be the degree of dissociation. So let us say 0.5 minus 0.5 alpha. This will become 0.5 alpha. This will become 0.5 alpha. Okay. So what should be the value of I? 0.5 minus 0.5 alpha plus 0.5 alpha plus 0.5 alpha to be divided by 0.5. This and this will get cancelled. So I value will be 0.5 plus 0.5 alpha to be divided by 0.5, right? And this is quite simple, right? I will be 0.5, 0.5 will be common, so 1 plus alpha. Alpha is 0.8, so this is 1 plus 0.8, that means 1.8. Clear? So I will be 1.8, 18 by 10, multiplied by the concentration is 0.5 molar, so that is 5 by 10. Okay, so this is 90 by 100, giving me a value 0.9. So the IC value is 0.9 and we need to say that the same IC value should be obtained for the other solutions also. Fine. So let us see what can be the IC values for other solutions. Do remember this value 0.9. See, if I have done in with a long method, but if you people remember the correlation between I and alpha for NaCl, that is also easy. Then also you can use a direct. So the first says 153.9 grams of sucrose. The molar weight is 342 grams per mole, is dissolved in 500 ml of solution. So we need to calculate the value of IC. Okay. Now I is, so see, IC will be, I is 1 because it doesn't undergo dissociation. Concentration is 153.9 divided by 342. So these are the number of moles. By volume of solution in liter, 500 divided by 1000. And if you do the calculation, you will actually get the value 0.9. So yes, since IC value is 0.9, so this will be isotonic. Clear? Moving on to the second part. The second part says .3 molar Na2SO4 undergoing 100% ionization. So when 100% ionization is there, you will get 2 Na plus and SO4 2 minus. So see, IC value will be 2 plus 1, 3. I value is 3 into concentration is 0.3. So once again, IC is 0.9. Since IC is same, so even this will also be isotonic. Okay. Moving further, it says, third part, 1.8% W by W, weight by weight of aqueous NaOH undergoing 100% ionization. So we need to get IC value. So I for sure will be 2 because NaOH will give Na plus and OH minus. Now what does this 1.8% weight by weight means? So 1.8 means, can I say 100 grams of solution will have NaOH how much? 1.8 grams. Okay. Now if I want you to tell me the concentration, then you can say given mass, which is 1.8, divided by the molar mass of NaOH, which is 40 grams per mole, right, by the volume of solution in liter. So when you will be doing the volume of solution in liter, as such, I'll tell you there is one simple tricky thing. As such, the volume of solution is not given. However, you are given that 100 grams of solution is there. So if you would have been given the density, first you would have calculated the volume. Fine. But if it is not given, let us just assume it to be 100 ml. So when you assume it to be 100 ml, so let's say this becomes 10. So 100 divided by 1000, 2, 1 will go with 1. So see, approximately it is coming to be 0.9. Or else I would have corrected the question if it would have been given W by V. So that would also be same thing. So even this will be isotonic. Okay. Moving on to the last one, 1.2 molar benzoic acid in solution where the acid dimerizes to an extent of 50%. So if I am saying that the acid is undergoing dimerization, so see, so 1.2 molar benzoic acid and they are going to form a dimer. Okay, and this is 1.2 and this is nothing. Okay, so let's say this becomes 1.2 minus, so let's say alpha is undergoing, so if I am saying the degree of dissociation is alpha, so alpha is amount dissociated divided by total amount taken. So 1.2 alpha is the amount dissociated. Okay, so the left out will be 1.2 minus 1.2 alpha. Clear? And how much will be formed? So see, 2 benzoic acid will form 1 molecule. So 1 will form 1 by 2 molecule. So 1.2 alpha will form 1.2 alpha divided by 2. That means 0.6 alpha. Okay. Now what should be the value of I? So the value of I should be 1.2 minus 1.2 alpha plus 0.6 alpha to be divided by initial, which is 1.2. So I will be 1.2 minus 0.6 alpha to be divided by 1.2 and alpha is given to be 50%. So see, once again if you go, so alpha is 50%, 1 by 2 minus 0.6 into 1 by 2 divided by 1 by 2. So this comes out to be 1 by 2 minus 1.2 minus 0.3 to be divided by 1.2. Okay. So if I further solve it, I will be getting 0.9 divided by 1.2. This is the value of I. And if I ask you to multiply it with C, which is 1.2. So see, again the value of IC is coming out to be 0.9. So even this is isotonic. So the question says all the 4 options A, B, C, D will be the correct option for this particular question. This was really a very good, interesting and yes, a very nice scoring question. So that you should have done properly. Okay, so nice question. Now we need to move on to the other question. So let me just prepare the board. Next, I think I have taken some calculative questions. Less conceptual but more calculative. The question is a paragraph question, and the question says 1 mole of liquid A and 9 moles of liquid B are mixed to form a solution. So liquid A is the liquid B, 1 mole of liquid A and 9 moles of liquid B are mixed to form a solution. If P naught B is given to me as 400 mm of Hg and P naught A is given to me as 20 mm of Hg at a temperature T, the normal boiling point of B is 300 Kelvin. So TB naught is 300 Kelvin. Then answer the question that follows. The Kb value is given to me 2.7 Kelvin kg per mole, and the molar mass of B is 100 grams per mole. So I think there will be 3 questions that will follow. Question number 8. So it is observed that the pressure of vapors above the solution at T Kelvin is 350 mm of Hg. That means when you will prepare a solution with the following data, the vapor pressure has been observed to be 350 mm of Hg. You need to tell the true statement. Okay, so let's see. If I assume the solution is ideal solution, or if I just apply Réaule's law, then we can say pressure of solution is equal to P naught A XA plus P naught B XB, right? So P naught A is 20, XA will be 1 divided by 10. So P naught B is 400, XB will be 9 divided by 10. And if you do the calculation, I have already calculated, the answer came to be 362 mm of Hg. Okay. So if the solution would have been an ideal solution, then the pressure would have been 362 mm of Hg. But the pressure obtained is lesser than 362. So don't you think there is a negative deviation from Réaule's law? Okay. So he is saying that the solute-solvent interactions are weaker than solvent-solvent or solute-solute interaction. That's no, because it's a negative deviation. That means final vapor pressure which is coming is lesser. So when final vapor pressure is lesser, that means solute-solvent are interacting more compared to individual solute-solute or solvent-solvent. So even this is wrong. But he says the volume of final solution will be lower than the sum of individual volumes. Yes. When the two will be interacting more, then don't you think they will be close together? So the final volume will be lesser compared to the volume of individual solutes and solvents. Moreover, we can say, right, delta V mixing, if it is less than 0, this corresponds to the negative deviation. So option number C will be the correct option. D says that the enthalpy change due to mixing will be 0. No, no, no. Enthalpy change will also be not equal to 0. It will be lesser than 0. Okay. So this was about our question number 8. Not a tough question, but only on the basis of little of calculation you would have got a very serious and an easy answer. Now moving on to another question, which is question number 9, which says that if A is assumed to be perfectly non-volatile, A is non-volatile, Okay, then what will be the normal boiling point of the solution? So you need to calculate the boiling point of solution. Like if A is non-volatile, then don't you think B is just considered to be solvent? So I can say that delta TB is equal to KB into molality. Now delta TB means earlier. So see, delta TB means TB minus TB naught. KB is given to me and we need to calculate the molality. So if I put all the values, this is not needed. Yeah, these two are needed. So let me put the values here only. So TB I need to calculate. TB naught is 300 and both the two are there in Kelvin, is equal to KB is 2.7 Kelvin kg per mole. Kelvin will get cancelled, divided by molality. Now what is molality? Molality of the solution in the terms of solute. So molality will be number of moles of solute, which is 1 mole of A, divided by mass of solvent in kg. Now mass of solvent means, see, molar mass is there as 100 grams per mole. And how many moles are there? 9 moles. But this is to be written in kg. So this gram will also be cancelled. Okay. So mole per mole got cancelled. Then we have this mole, kg, kg. And if you finally find out the value of TB, the answer comes out to be, again I did the calculation, 303 Kelvin. Okay. Again a good question. I mean, I really like the question because it's really cool. Now I think with this particular question, we can now come on to the last question of today's class. And the question is, if A is again perfectly non-volatile, and it dimerizes to an extent of 60%. That means A is undergoing a dimerization reaction. Okay, let me just remove it. So if A is undergoing a dimerization reaction, I can write 2A will be forming A2. Okay. So let us just consider at T is equal to 0, you had 1 mole of A. This is nothing. At T is equal to T, let us say alpha is the degree of dimerization. So alpha is amount dimerized divided by total amount taken, 1. So amount dimerized is, let us say, alpha. So if I now call it as 1 minus alpha, okay. Now see, what should I be calling in the further extent? So if I say 2 will be combined, it will be forming 1. If 1 combines, it forms 1 by 2. If alpha combines, it forms alpha by 2. Okay. Now if I move further, can you calculate the value of I? So I will be 1 minus alpha plus alpha by 2 to be divided by 1, which becomes 1 minus alpha by 2. Alpha is given to 60%. So that means 0.6. 1 minus 0.6 divided by 2, 1 minus 0.3, 0.7. So the value of I in this particular question comes out to be 0.7. Now he is saying what will be the vapor pressure of the solution. So once again, to calculate the vapor pressure, I will say that, so see, now he is asking you to calculate the vapor pressure of solution. So don't you think I can once again do delta P by P naught is equal to mole fraction of solute, but this time multiplied with I. Okay. So delta P divided by vapor pressure of pure B was 400. Okay. So this was the vapor pressure of pure B, which was given to us as 400 to be divided, so which will be equal to the value of I as 0.7 multiplied by, once again we need to calculate the mole fraction of, so we need to calculate the mole fraction of solute. So mole fraction, how to calculate the mole fraction of solute, which is A. So don't you think mole fraction of A is number of moles of A divided by number of moles of A plus number of moles of B? Now number of moles of A are just 0.7 divided by 0.7 plus 9. Okay, so here you will do the calculation and you can substitute it here. I value is already given to you. You can take the 400 there. You will get the value of delta P. So once you do the get the value of delta P, so you can say delta P is equal to P naught minus P. This is known. You can easily calculate the value of P. And if you solve, I think I have solved it, the answer will come out to be 3600 divided by 9.7. Check it out because I did it and I was getting this answer. You also check it out. Okay. So guys, this was the question number 10th of JEE Advanced Pattern paper. And I think with this particular thing, we are now completely done with the chapter solutions. So once this chapter is done, I will be giving you a homework, and the homework is you first of all need to watch all the recordings, the previous ones and these ones, and then you need to pick up like 10 to 15 questions from the past year papers that have been asked. Try to sit properly, try to set a time limit and solve the 20 questions or 30 questions, whatever will be there. And yes, please do not forget to calculate your marks, +4, -1, follow it. Try to take a minute or 1.5 minutes for each question and the things will be very cool. Okay, so this was all about the chapter solutions. Now we'll be meeting once again with the next chapter, that is electrochemistry. So before we meet next, you need to take care. Thank you and goodbye.